Lesson 2.6 is titled The Quadratic Formula. Now, the quadratic formula is a pretty intense-looking formula that helps solve quadratic equations. Be specific when you write the formula down and make sure you have it written exactly the way I do. If we're solving for x, we would write x equals negative b plus or minus, and then kind of a big square root, b squared minus 4 times a times c, all over, there we go, all over 2 times a. If we're using the coefficients for a, b, and c, that means our equation needs to be in standard form. And if you look at the two examples on the right, we're in that form. So we have y equals ax squared plus bx plus c. A is always the coefficient in front of x squared. Uh-oh, what did I just do? Hang on. There we go. A is always the coefficient in front of x squared. B is always the coefficient in front of x. And c is always the constant. Now, when you solve with quadratic formula, you can have real solutions and you can have complex solutions. So if we get I, we have to if we get a negative on the inside of the square root, we have to simplify with I. Last but not least, just be careful when you simplify. Watch your negatives and that kind of thing. So be careful when simplifying. All right, let's try the two examples on the right. Solve using the quadratic formula. Notice each equation is set equal to 0. That means we're solving for x. Now, if we look at that first example, I notice we have a coefficient in front of x squared. If I take 3 and negative 9 and connect them, a times c is negative 27. So notice we can't come up with numbers that multiply to get negative 27 that would also add to get negative 4 in the middle. So it doesn't work to use the factoring method. Quadratic formula is just an alternative to that. So if we follow our rule for negative or x equals, we would have x equals negative b, and b is negative 4, plus or minus, and then our square root, b squared minus 4 times a times c. All over, now it's a big fraction, all over 2 times a. Once you have everything plugged in, now it's just a matter of simplifying. And this is where we want to be very careful. A double negative for negative 4 makes that positive 4. Plus or minus. On the inside of the radical, negative 4 squared is 16. And then we have minus. 4 times 3 times negative 9 would be negative 108. All divided by 2 times 3, which is 6. With that double negative on the inside, it changes to positive. That gives us 4 plus or minus the square root of 16 plus 108, which was 124, all over 6. Now at this point, you're going to want to simplify the square root, then reduce the fraction if possible. So simplify, then reduce. 124 isn't a perfect square, but it has a perfect square factor. There's a number that goes into 24 that is a perfect square. That's 4 times 31. Now 4 would come out as the square root of 4, which is 2, giving us 4 plus or minus 2, and then 31 stays on the inside. Nothing else goes into 31, that's a perfect square. Divided by 6. The radical is simplified as far as it can go. Once you're at that point, look at all the numbers on the outside, to the left of the plus or minus, to the right of the plus or minus, and on the bottom. All three of those numbers can be simplified or reduced by a common factor of 2. 2 goes into 4 twice, into itself once, and into 6 3 times. Reducing this fraction gives us 2 plus or minus the square root of 31 over 3. Now, if you were asked to split that, you could do 2 plus square root 31 over 3, and then 2 minus square root 31 over 3. And that's using quadratic formula as an option to solve. Again, if we would have tried to factor, it wouldn't have worked. Let's try the next one. Again, it's the same idea, but now looking at your a value, notice a number isn't written. Technically, then, your a value is just 1. Give myself a little bit more room here. I'm actually going to make my screen kind of fit my space a little bit, give myself a little bit more room on the right. There we go. And now let's see what we can do. There we go. Now let's see what we can do with our quadratic formula. X equals negative b. Oops, I wanted purple. All right, I know. Oh, whoa, that was kind of fun. Kind of did a faded color there. All right, x equals negative b. So we have another double negative, negative 9. Plus or minus the square root b squared minus 4 times a times c. So we're going to have to multiply all of that together. All over 2 times a. From here, again, we have our double negative, changes to positive 9, plus or minus, oops, I forgot the squared before. Hopefully you caught that. Negative 9 squared is positive 81. Minus 4 times 1 times 27 is positive 108. So now it stays a subtraction problem on the inside. Before it was addition, now it stays subtraction. In the denominator, 2 times 1 is 2. If we take 81 minus 108, we get negative 27 all over 2. So now think about, with that negative, we'd want to factor out the negative part with an I, and that would give us 9 plus or minus I times 27 over 2. Simplify the radical, then reduce if possible. Now 27 isn't a perfect square, but 27 can be broken down into 9 times 3. And 9 is a perfect square. This would give us 9 plus or minus, the square root of 9 is 3, so that's 3 times I. But then we have that 3 on the inside still, all over 2. Looking at your numbers on the outside, we have 9, 3, and 2. Nothing goes into all 3 of those numbers evenly, therefore our fraction is reduced, and these would be 2 complex solutions. To figure out the kind of solutions or roots that a quadratic function has, you can use what's called the discriminant. Now the discriminant is just part of quadratic formula. It's the b squared minus 4ac part. So you only have to use part of it when you're asked to simplify or determine the number of solutions. If b squared minus 4ac is greater than 0, so a positive number, that means you have 2 real solutions for your graph, which means you have 2 actual x-intercepts. If b squared minus 4ac equals 0, so that the square root cancels out, you have 1 real solution. So that means the x-intercept is also the vertex. Lastly, if b squared minus 4ac is less than 0, that means the inside of your radical is negative. And that means there are 2 complex or imaginary solutions. So you're not actually solving for the value of your intercepts, you're just determining the number that they are. So it says use the graph to determine the number of roots, and roots are the same as zeros. Just another way to describe it, for each quadratic equation. Looking at that first quadratic, it's graphed as a parabola, y equals 2x squared minus 7x plus 3. Just by looking at the picture, you can see that it crosses the x-axis at 2 spots. To verify with the discriminant, take b squared minus 4ac. B is negative 7. That would be negative 7 squared minus 4 times a times c. Negative 7 squared is positive 49. 4 times 2 times 3 would be minus 24. And that's a 24, sorry. We'll get that in there. 49 minus 24 is 25. 25 is a value that's greater than 0. And that validates the discriminant definition of 2 real solutions. Pause the video and try the second one. Okay, any chance you got 0? B squared minus 4ac would be 12 squared minus 4 times 4 times 9. 144 minus 144 equals 0. And that defines the discriminant, or the quadratic, as having 1 real solution. Take a look at your graph and notice the vertex is on the x-axis. All right, last one. Again, pause the video if you would, and see if you can determine why that quadratic function actually doesn't cross the x-axis. For that last example, if we apply the discriminant definition, b squared minus 4ac, you get negative 28. And since negative 28 is less than 0, that would indicate you have 2 imaginary solutions, which means the quadratic function does not cross the x-axis. Now tomorrow, we'll finish the rest of our notes for 2.6.